Good morning. The trigonometry assessment is the only maths you'll need to do this week. It's going to be on Education Perfect. You've been given an hour and a half. It shouldn't take you that long, but we have given extra time just in case your internet's a bit slow or you get stuck somewhere that you've got time to think it over. And I thought it'd be a good idea for me to go through what we are looking for. So you're going to be given a shape, obviously not this one, but something similar, some triangles joined together. You'll be given a short description. I've made this one up. For example, Bob is designing a shape and he's got some requirements. And then it's going to step you through what you need to calculate. So for example, here it says, are all the internal angles greater than 50 degrees because he doesn't like sharp corners. So what that means is you actually have to calculate all the internal angles and then see if they meet his requirements or not. And then the next question is asking me to find the perimeter and area, which you will have to do as well. And then the last one is you're adding another triangle to this shape. Remember, for perimeter, it is the outside edge. So this length here would not be part of the perimeter. It's only the outside. For the area of a triangle, it's my base times height times a half. So remember, the height is always right angles to the base. And now, to pass, I need to demonstrate 3 different skills at least once. So I have to use Pythagoras theorem to find a side. That's the hypotenuse squared is equal to the opposite two sides squared. Use trigonometry to find a side. So that's using any angle in any other side. I have to find another side correctly. And then use trigonometry to find an angle. I have to show these skills correctly at least once each to earn achieved. This fourth one won't apply to us because we're not actually taking any measurements. But if we were actually measuring an object, we'd get a mark for that too. And then for merit, what we have to do is calculate all the angles correctly, all the side lengths correctly, and put it in context, answering the question that was asked. And for excellence, we're adding another shape. So I'll go through step by step what we have to do. Remember that my sine angle equals opposite divided by hypotenuse. So if I want to find the side that's opposite my angle, that means my opposite side, I multiply both sides by h, is equal to h times sine angle. And if instead I wanted to find the hypotenuse, I would multiply both sides by h still, and then divide by sine angle. So h equals O divided by sine angle. And cosine angle is adjacent over hypotenuse, which means if I want to find the adjacent side, it's cosine angle times hypotenuse. And if instead I wanted to find the hypotenuse, then it would be my adjacent divided by cosine angle. By the way, you are allowed a resource sheet for the assessment, so yeah, it's a good idea to write one. And tan angle equals opposite over adjacent, which means that my opposite equals tan angle times adjacent. Or if I want to find the adjacent side, that's equal to opposite divided by tan angle. So for this shape I've drawn here, I can see there's a little right angle there. What that means is this line is parallel to this line here because this also has a right angle. So this line is 6 meters. So I've got this side is 6 meters, this side is 10 meters, and let's say I want to find this angle here. This letter is BDA, so I'm going to write down angle ABD, because B is my middle letter, ABD, that's my angle. And I've given the opposite side and the hypotenuse side. So I go back to my little triangle here, and which one of these uses the opposite side and hypotenuse? I can see that it's sine angle equals opposite of hypotenuse. And my opposite is 6, and my hypotenuse is 10, which means my angle is equal to inverse sine 6 divided by 10. I get out my calculator, make sure it's in degrees, which it is. And that's going to give me 36.87 degrees. Now, because this is an it's an isosceles triangle, which I can see because these indents mean these two sides are the same length. And remember, base angles of isosceles triangles are equal. So angle ADB is the same as angle ADB is the same as angle ADB, same as ABD. Sorry, that didn't, yeah. So this angle is the same as this one here, which means that angle ADB is also equal to 36.87 degrees. Cool. Now, this angle up here, that's DAB. Remember, angles in a triangle add to 180. So this angle here is going to be 180 minus these two angles. So 180 minus 36.87 minus 36.87 equals, use my handy calculator, 106.26 degrees. So you can see that my diagram is not drawn to scale, which might happen. It's 26 degrees, yeah. Okay, now I need to find this angle here. So that's angle EDA. And to find this angle, because these two sides are the same length, because it's isosceles triangle, this is 10, so this is 10, and I use my formula sheet and see which one of these things uses the side that's adjacent to my angle and the side that's the hypotenuse. And I see cosine angle equals adjacent divided by hypotenuse. And here, my adjacent side is 6 meters, hypotenuse is 10 meters. I'm going to use my handy calculator. And I see I get 53.13 degrees. Okay. And then the last angle I have to calculate is angle EAD. And I see I've been given the opposite and the hypotenuse, so I know to use sine. My opposite is 6 meters, my hypotenuse is 10. And we've done that before up here, and I can see that it's 36.87 degrees. Okay, so now I have to write a sentence answering the question. We wanted to see if all the angles were bigger than 50 degrees. And I know that this angle here is 36.87 because we just calculated it, which is less than 50 degrees. This is the other internal angle. It's bigger than 50 degrees, as is this one up here. So then angle ABD equals which is less than 50 degrees. So this angle doesn't meet his requirements. Okay, for the next part, to calculate the perimeter, we want all these outside edges. But remember, we don't want to use just Pythag or just trig. We want to use both skills at least once. So let's calculate length EA. For EA, this is my longest side and these are my two shortest sides. So 10 squared equals 6 squared plus EA squared, which means EA squared equals 10 squared minus 6 squared. That's going to be 8. Cool. So I can label it up here. This side is 8 meters. Now I need to find this bottom one here. I don't want to use Pythag. I want to use trig, because remember, I want to show that I can actually use trigonometry to find a side. And we calculated this angle here to be 36.87 degrees. And this is the adjacent. So cosine my angle, which is 36.87, equals my adjacent, and my hypotenuse is 10. That means my adjacent side is equal to 10 times cos 36.87, which is that looks like it is 8 meters. Cool. But remember, I've just calculated this side here to be 8 meters. And this base length is both this CB and DC. So my actual base length is going to be 16 meters. So so if this is 16, 6, 8, 10, that's going to be my perimeter. And I'll just type that in my calculator just so I don't do a simple mistake. 16 plus 6 plus 8 plus 10. And that gives me 40 meters. So I can write my perimeter is 40 meters. So next part is the area. Now the area of triangle DEA, I'll do that first. It's half times base times height. And if my base is 8, my height has to be right angles to the base. So base 8, height 6. And that's going to give me 24. I have to include units. Let's say it's meters squared. And then for this triangle here, ADB, my base is 16, my height is 6, which is going to give me 48 meters squared. So the total area is the area of my two triangles. That's going to give me 48 plus 24, which is 72 meters squared. Now when I'm adding another shape to this one here, for the last part I'm adding a shape, and I have to know the types of triangles. Remember, an equilateral triangle has all three side lengths the same, all angles are 60 degrees. A scalene triangle has all three sides different, so I'm drawing different indents here, and all three angles are different. This one is equilateral. An isosceles triangle, if these two sides are the same, that means my base angles are the same. So 2 sides equal, 2 angles equal. Remember, you can also have a right-angled isosceles triangle. So if this is 90 degrees, because it's a right angle, it needs 2 sides to be the same. It has to be the 2 sides that are adjacent to my right angle, because I can't have the hypotenuse being the same with something else. So if this is 90 degrees, these 2 sides are the same. Angles in a triangle add to 180 degrees. So that means 90, if I take away 90 from 180, I have 90. So these 2 angles must be 45 degrees. And I can have a right angled triangle that's not isosceles as well, of course, which is what we usually are dealing with. But these scenarios can all happen. So if I'm adding, what does the question ask for? So I'm adding an isosceles triangle in this case with a height of 8 meters, and then I find the new area and perimeter. So onto my diagram, it says it's the one that's adjoining side AB. So here I'm going to add a triangle which has a height of 8 meters, and it's an isosceles one. So if this is my base, this is my height, these 2 sides are the same, which means if this whole length is 10, the half length is 5, and then this is 8, and then I can use Pythag to find these 2 sides, and to find this area, it's still half times my base times my height. If you have any questions, oh yeah, I didn't finish the question because it's once you've drawn the additional shape, then you use the same skills you used before for merit, and then obviously answer the question in context. And that's all I had to say. Yeah, thank you guys.